Right, hi, good day everyone. Today we're going to be doing May, June 2025, number 8, paper 2. May, June 2025, number 8, paper 2. So let's look at this. This immediately is a quadratic, right? Curve, a parabola, if you want to call it like that. Right, the following diagram shows the graph of a function y is equals to x squared plus x minus 2. Right, so I like to, whenever I see something, I like to see what I can get from this, which is, I know that when x is negative 2, when x is negative 2, y is 0. So the solutions for this, so when y is 0, when y is 0, right, I have negative 2, hold on, negative 2, 0, and 1, 0. I also have when x is 0, y is negative 2, right? Yeah, that's about it that I can find out here. We could probably also try to find the axis of symmetry, but let's not do that. We'll use the formula. Right, from the graph, the roots of the function. The roots of the function is basically when when y is equals to 0. So the solution for this, I already wrote it, is x is equals to negative 2 and x is equal to 1. The coordinates of the y-intercept, where it intersects on the y-axis, we already put that, that's negative 2. The minimum value, now there's a formula for this, which is, so to get your minimum value, you have to remember that you have to use this equation, that x is equals to minus b over 2a, and whatever value you get here, you're going to substitute it into the equation, x is equal to that, and that would give you a minimum, or, well, in this case it will be a minimum value. You can also kind of try to figure it out here. Your minimum value is this value here. I would say it's like 2.5, negative 2.5. But let's try to figure it out using this. So x is minus, so we know that the equation is x squared. Oh, why I put 2 at the end there? Hold on. Let's zoom in. Right, so we know that equation is x squared plus x minus 2. X squared plus x minus 2 plus x minus 2. Right? We know that x is minus b over 2a. A is 1, b is also 1. So that's minus 1 over 2 by 1, which is minus a half. Right? Put that into the equation. That would be minus a half squared plus a half minus 2. So that would be a quarter plus 1 over 2 minus 2, which would be negative 1 and a quarter. So let's just check that out here. This is supposed to be negative a half. This was supposed to be negative a half. Yeah. So it would have been minus, 1 over 4 minus 1 over 2 minus 2, which would be 2 and 1 minus 2 and a quarter. Right? So if you look at the graph here, each little point here is from 0 to negative, some 0 to 2 is 5 little spaces, so that would be one space would have been, if 5 spaces is equals to 2, then one space would have been 2 over 5. So this would have been right here, and that is how we get negative 2 and a quarter to get the exact answer for this question. Right, so the minimum value is negative 2 and a quarter. Right, so to get your minimum value, you put, to find your x value, put minus b over 2a, substitute it back into the quadratic, and that would give you your minimum or maximum value. There's negative 1 over 4. Then they said the equation of your axis of symmetry. That's what this is for. X is minus b over 2a, which we got x is equals to negative a half. Right, and that would be your axis of symmetry. Even if you look at it here, right, your axis of symmetry is a turning point. Right, if you were to, if I could do it here, yeah, were to do it like somewhere, not there, like right here. Right, that is directly in the middle of 0 and negative 1. So this is minus a half. Right? Negative a half. So x is negative a half, and then you could have used the graph to calculate it. You may be a little bit off, or you could use the formula and you would get the same thing. On the same pair of axes on page 24, draw and label the line y is equals to 2x plus 4. So anytime you have to do that, I always like to say let x be when x is equals to 0 and when y is equals to 0 to get two coordinates. So when x is equals to 0, y is equals to 4. And when y is equals to 0, I have 2x plus 4 is equals to 0. So I have 2x is equals to minus 4, so x is equals to negative 2. So x is equals to negative 2. So these are your two coordinates, 0, 4 and negative 2, 0, that you will plot and then be able to label. So 0, 4, that is x is equals to 0 on your, I'm going to do it in red, but you will have to do it in pencil. That is right here. Right, x is 0, y is 4. Next one is negative 2, 0. So negative 2, 0 is right here. Right, so if I was to draw this, it would be, hold on, right here. And that would be the line y is equals to, y is equal to 2x plus 4. Let's do this in black. Y is equals to 2x plus 4. Right? Using the graph, determine the solution of a pair of the pair of simultaneous equations. So using the graph, I could see it intersected here, so that means, excuse me, it would be 0, x is 0, y is negative 2, right? And if I extend my line, right, let's just zoom up here, and I extend my line, I would get this coordinate here, 3, 10. So 3, x is 3, y is 10. 3, 10 for my solutions. Now you can, they told you use the graphs, right? So let's substitute these values into here and see if we'll get it. So 2 threes are 6. 6 plus 4 is 10. So this here works for this equation, and then I have x is 0, 2 by 0 is 0, yeah, that does. Did I have negative? Yeah, x is negative 2, 0. Right, so if you look the working right here, when x is 0, this here is negative 2, 0. Not 2, 0, not 0 negative. So it's negative 2, 0. So when y is 0, x is negative 2, and then we can substitute it into this here and see if we're getting it correct. So we would use a calculator. Let me just show you how to use the calculator to do this. Right. So you would say these are my x values and these are my y values. So when I'll have negative 2 squared plus negative 2 minus 2, I'm supposed to get 0, which I do. So it works for this first one. Now I'll do the same thing. 3 squared plus 3 minus 2, and I am getting 10. Right? So these two points do work for the first equation. Let's see if it works for the second one. I have 2 by negative 2 plus 4, I am going to get 0, and then 2 multiplied by 3 plus 4 is equals to 10, right? And that is how you would know that this is correct. So the solutions for the pure simultaneous equations is x is negative 2, y is 0, and x is 3, y is 10, right? And that would be the answer. Okay, let's look at this question. We know just by looking at it, it's a velocity time graph, but let's read it and see what they're asking you. Right, the following diagram shows a velocity time graph of a car journey from tongue R to tongue Q. The car accelerates for 2 minutes and travels at a constant maximum speed and slows to a stop. Okay. Alright, so let's see what they ask you. Determine initial acceleration. So your acceleration is actually a gradient. So if I can get the gradient of this line, so that is 0, 0. Let's just put that. The first coordinate here is 0, 0, and the last coordinate here, we know that this is 120, x is 120, y is 30. So these are the coordinates that you're going to use. 0, 0, and then 120, 30. It is, my gradient is y2 minus y1 over x2 minus x1. Doesn't matter. I'll choose this one to be this one to be x1, y1, this one to be x2, y2. So I have 30 minus 0 over 120 minus 0, which would be 30 over 120. Right, which would be a quarter, which is 0.25, and because its acceleration will be meters per second squared. Right, calculate the distance between the two towns. Now to calculate distance, it is your area of your trapezium, right? So let's just get the coordinates here. This is this is 60, this would be 120, so it's every 60. So this here would be 780 plus 60, which is 840. So this here is 840. And this one here, when we go down, that should be 600. So this is 600 here. So this x is 600, y is 30. Alright, so now we have all the coordinates. We can simply find out the area. Now area of a trapezium is equals to half by a plus b by your height. A is the length of, A and B is the length of your parallel sides. So from here to here, let's say A is 840 and B is the distance from 120 to 600, so that's 600 minus 120 is 480, and height would be 30. So I'm going to put this in. That would be a half by 840 plus 480 by 30, 1 over 2 by 840 plus 480, 30 multiply by 30, which would be 19800, and this is in meters. Alright, so if you want it in kilometers, you can convert it, but that is how did they ask you. So the distance between the two towns is 19,800 meters. Right, so again, the area of your trapezium, or the area under the shape, is your distance traveled. Right, yeah, so it would be 19,800 meters, and that is the end of number 8, paper 2.